Morning. So, in the last class, we discussed about the IIR digital filter structures. Okay, IIR digital filter structures. Here we have 7 techniques are there. Okay, direct form 1, direct form 2, transposed form 1, cascade form 1, parallel form 1. Okay, like that we have 7 techniques are there, and we have done some problems related to those techniques also. The same manner, we have FIR digital filter structures are there. These are also called as non-recursive realization techniques. So here we have 3 techniques are there. First one is direct from realization or transversal realization or tap delay line filter. That is the first technique. Second one is cascade realization, and third one is linear phase realization or minimum number of multiplier realization techniques. So first one is direct from realization technique. Okay, transversal realization or tap delay filter. Okay, so here if the system has finite duration impulse response sequence, then it is called FIR system. Okay, so if the length of the impulse response is n, then h of n equal to h of 0, h of 1, h of 2 up to h of n minus 1. Okay, transfer function of h of n is nothing but h of z. So h of z equal to y of z by x of z, right? So now we are taking the z transform of h of n, that is nothing but h of z. So Z transform of h of n is nothing but sigma n equal to 0 to n minus 1 h of n into z power minus n. Or it is equal to sigma n equal, replace n by k. So k equal to 0 to n minus 1 h of k into z power minus k. So y of z equal to sigma k equal to 0 to n minus 1 h of k into z power minus k. Okay. So into x of z. Why? Because the transfer function is equal to output by input, that is y of z by x of z. So y of z equal to x of z into h of z. H of z is already this one, this into x of z. Now we are applying inverse z transform for this one. So by applying inverse z transform, we will get the original signal, that is y of n is equal to inverse z transform of this entire expression. So sigma k equal to 0 to n minus 1 h of k into z power minus k into x of z, right? So it is equal to sigma k equal to 0 to n minus 1 into h of k into inverse z transform of, okay, z power minus k into x of z, right? So z power minus k into x of z is nothing but x of n minus k. Okay, so by expanding this, we'll get h of 0 into x of n plus h of 1 into x of n minus 1, like this. Okay. Question number 1. So we can draw the direct form like this. So x of n into h of 0 plus x of n minus 1 into h of 1 plus x of n minus 1 into h of 2 plus up to x of n minus 2 into h of n minus 2, okay, equal to y of 1, right? Okay, so this realization requires the total number of multipliers are n. Okay, n number of multipliers are there, and total number of adders are n minus 1. See, these are all the adders. Okay, so and memory locations are also n minus 1. This is a direct form. Okay, direct form realization technique. Direct form realization technique or transversal realization or tap delay line filter. This is called. Second one is cascade realization. Okay, second one is cascade realization. So this realization is implemented all the subsystems of system function. Cascade means side by side. So the output of the first stage is connected to the input of the second stage. Output of the second stage is connected to the input of the third stage. Output of the third stage is connected to the input of the fourth stage, like that. And output of the n minus 1 stage is connected to input of the nth stage. Okay, so this realization is implemented all the subsystems of system function h of z can be connected in series, that is cascaded manner. Okay, cascaded manner. If n is odd, suppose n is odd, then h of z is equal to phi of k equal to 1 to n minus 1 by 2 into hk of z, that is phi of k equal to 1 to n minus 1 by 2 into hk is nothing but b naught b0k plus b1k into z power minus 1 plus b2k into z power minus 2. So sigma phi of k equal to 1 to n minus 1 by 2 of b naught of k is nothing but h1 of z, h2. This is nothing but h1 of z into h2 of z into h3 of z up to hn minus 1 by 2 of z. If this n is odd, then n minus 1 by 2 is nothing but even number. So h of z have n minus 1 by 2 second order system. Okay, right? So hk of z is equal to yk of z by xk of z, that is b0k plus b1k into z power minus 1 plus b2k into z power minus 2, right? By taking inverse inverse z transform for this one, then yk of n is equal to b0k into xk of n plus b1k into xk of n minus 1 plus b2k into xk of n minus 2. Let it be taken as equation number 1, right? So this can be drawn like this by using direct form. And that is b0k into 1, b0k into xk of n plus b1k into xk of n minus 1, b2k into xk of n is equal to yk of n. Similarly, xn into this is xn. So this into xk of z. What is xk of z? Xk of z is nothing but xn into b0 of 1 plus b11 into xn minus 1 plus b21 into xn minus 2. Okay, this is h1 of z. Similarly, this is h2 of z, h3 of z up to hn minus 1 by 2 of z. Okay, right. So if n is even, if n is odd, then this is the structure. Above is the structure. If n is even, it has one first order system and n by 2 minus 1 second order system. So it is h of z is equal to b01 plus b11 into z4 minus 1 into phi of k equal to 2 to n by 2 hk of z. So it can be written like this. So b01 plus b11 into z4 minus 1 into phi of k equal to 2 to n by 2 b0k and plus b1k into z4 minus 1. This is second order system. This is first order system. So one first order system and n by 2 minus 1 second order system, right? So this is first order system and this is second order system. Whereas for the n is odd number, only we have second order system, right? This is the second order system, right? So that is n by n minus 1 by 2. So one first order system and one second order system. Okay. So b01 plus b11 into z4 minus 1 into phi of k equal to 2 to n by 2 b0k plus b1k into z4 minus 1 plus b2k into z4 minus 2. This is one first order system and one second order system. Okay, then it will become b01 plus b11 into z4 minus 1 into h2 of z into h3 of z into up to hn by 2 of z. Okay, right? So xk of z is equal to yk of z by xk of z, that is equal to b0k plus b1k into z4 minus 1 plus b2k into z4 minus 2, right? Yk of n is nothing but xk of n into b0k into xk of n plus b1k into z4 xk of n minus 1 plus b2k into x2k of n minus 2. Okay, xk into n minus 2. So this can be structured as h1z. H1z is b01 into b01 into x of n plus b11 into x of n minus 1. Okay. So b01 into x of n plus b11 into x of n minus 1. It will be cascaded with h2 of z. H2 of z is b02 into x of n plus b12 into x of n minus 1 plus b22 into x of n minus 2. Right? This is h2 of z. Similarly, this is hn by 2 of z. This is the structure of a cascaded realization. Right? Cascade realization. For n is odd, for n is even. And third one is we're going to discuss about the third one. We will do this problem. Realize the following system using direct form realization. Direct form realization. The given system is h of n equal to delta of n minus 2 into delta of n minus 1 plus 3 into delta of n minus 2 plus 2 into delta of n minus 4 plus 5 into delta of n minus 6 minus delta of n minus 7. Right? So h of n, we can solution is h of n equal to 1 minus 2 3 0, okay, 2 0 0 5 and minus 1. This is the solution. Okay, so we'll do this one. So h of z is z transform of h of n, that is sigma n equal minus infinity infinity h of n into z power minus n, right? So it is varying from 0 to 7. So it is sigma n equal 0 to 7 h of n into z power minus n, right? So this will become h of 0 plus h of 1 into z power minus 1 plus h of 2 into z power minus 2 plus h of 3 into z power minus 3 plus h of 4 into z power minus 4 plus h of 5 into z power minus 5 plus h of 6 into z power minus 6 plus h of 7 into z power minus 7, right? So, but h of z equal y of z by x of z, that is given as 1 minus 2 into z power minus 1 plus 3 into z power minus 2 plus 2 into z power minus 4 plus 5 into z power minus 6 minus z power minus 7, right? So, y of z equal to this into x of z, that is x of z minus 2 into z power minus 1 into x of z plus 3 into z power minus 2 into x of z plus 2 into z power minus 4 into x of z plus 5 into z power minus 6 into x of z minus z power minus 7 into x of z, right? Now we will apply inverse z transform and linearity property for this above expression. So y of n will become x of n minus 2 into x of n minus 1 plus 3 into x of n minus 2 plus 2 into x of n minus 4 plus 2 plus 5 into x of n minus 6 minus 1 into x of n minus 7. Okay, that is equation number 1. So for this one, we will draw the direct form. So x of n into h of 0 is 1, x of n into 1 plus x of n minus 1 into minus 2 plus x of n minus 2 into 3 plus x of n minus 3 into 0 plus x of n minus 4 into 2. Okay, plus 5 is 0, x of n minus 5 into 0, x of n minus 6 into 5 plus x of n minus 7 into minus 1. That is all will be summed here, so that we will get y of n. Okay, next that is about that problem. Next problem is realize the following system using cascade realization and direct form realization. Okay, cascade realization and direct form realization. H of z is given as 1 minus z power minus 1 plus 2 z power minus 2 plus 3 z power minus 3 minus z power minus 4. Okay, z power minus 4 into 2 minus z power minus 1 minus 4 z power minus 3 plus 5 into z power minus 5. So this is h1 of z into h2 of z. Okay, so from this one, h1 of z is nothing but y1 of z by x1 of z. Similarly, h2 of z is nothing but y2 of z by x2 of z. So from this expression, y1 of z can be written as x1 of z minus z inverse into z power minus 1 into x1 of z plus 2 into z power minus 2 into x1 of z plus 3 into z power minus 3 into x1 of z minus z power minus 4 into x1 of z. Similarly, y1 of n is equal to, by taking inverse Laplace transform, inverse z transform, it will become x1 of n minus x1 of n minus 1 plus 2 into x1 of n minus 2 plus 3 into x1 of n minus 3 minus 1 into x1 of n minus 4. In the same manner, y2 of n is 2 into 2 into x2 of z minus z minus 1 into x2 of n minus 1 minus 4 into x2 of n minus 3. Okay, uh, plus 5 into x2 of n minus 5, right? Like that. That is equation number 2. So from these two equations, y1 of n and y2 of these two will be added, so that we will get these two will be cascaded, so that we will get h of z equal to h1 of z into h2 of z. First of all, we will draw the h1 of z, that is y1 of n. Okay, that is h1 of z. Okay, so this is for equation number 1, x1 of n into 1 plus minus 1 into x2 of n minus 1 plus x1 of minus 2 into plus 2 plus x1 of n minus 3 into 3 plus x1 of n minus 4 into minus 1. That is y1 of n. This will be connected to here. Okay, so x2 of n, that is equal to x of n. So 2 into x2 of n plus x2 of n minus 1 into minus 1, x2 of n minus 3 into minus 4, x2 of n minus 4 into 0, x2 of n minus 5 into 5. So this will be added to by 2 of n. So this is h1 object and this is h2 object. Okay. So in direct form, we're taking multiply these two, and direct form means this is the direct form. We will do this. Okay. So this is cascaded form, and direct form is like first problem. This is about the FIR realization. FIR realization techniques. Next we'll see the linear phase realization. This is the third one. Linear phase realization technique or minimum number of multipliers required realization. This is also called as minimum number of multipliers required realization. Minimum number of multipliers required realization. For linear phase FIR digital filter, impulse response satisfies the following condition. Impulse response satisfies the following condition, that is h of n is equal to h of n minus 1 minus n for all values of n, where n is nothing but length of h of n. So that h of n can be represented as h of n equal to h of 0, h of 1, h of 2 up to h of n minus 1. So how to get h of n? By taking the Z transform of h of n, we will get h of z is equal to x of z is equal to sigma n equal 0 to n minus 1 h of n into z power minus n. That will become h of 0 plus h of 1 into z power minus 1 plus h of 2 into z power minus 2 up to h of n minus 1 into z of minus of n minus 1. So for case 1, if n is even, then h of z will become y of z by x of z equal to sigma n equal to 0 to n minus 1 h of n into z power minus n, right? So it is sigma n equal to 0 to n by 2 minus 1 h of n into z power minus n plus sigma n equal to n by 2 to n minus 1 h of n into z power minus n. Can we divide it like this? Put n equal to n minus 1 minus n and m equal to n minus 1 minus n, right? N equal to n by 2. Then m becomes n minus 1 minus n by 2, that is n by 2 minus 1. So if n is n minus 1, then m minus n minus 1 minus n minus 1, it is 0. Okay. So it will become z power minus n plus n equal to 0 to n minus 1 h of n is z power minus n plus sigma m equal to n by 2 minus 1 to 0 0 n minus h of n minus 1, n is n minus 1 minus m to the power of z power minus of n minus 1 minus n. Okay. Put m equal to 0 here. Then n equal to 0, n by 2 minus 1 h of n is z power minus n. Here n equal to n. So n equal to 0 to n by 2 minus 1 h of n minus 1 minus n z power minus of n minus 1 minus n. Okay. So h of n equal to h of n minus 1 minus n, right? h of n equal to h of n minus 1 n. So it is equal to sigma n is 0 to n by 2 minus 1 h of n into z power minus n plus sigma n equal to 0 to n by 2 minus 1 into h of n into z power minus of n minus 1 minus n. So h of z is equal to y of z by x of z, that is sigma n equal to 0 to n by 2 minus 1 h of n is common into z power minus n plus z power minus of n minus 1 minus n. Okay. So this will y of z equal to x of z into this entire expression. So it is equal to put n equal to k. So sigma k equal to 0 to n by 2 minus 1 h of k into Okay, z power minus k plus z power minus n minus 1 minus k into x of z. Okay, so now applying inverse z transform for this one and linearity property. So then y of n will become sigma k equal to 0 to n by 2 minus 1 which of k into x of n minus k plus x of n minus 1 minus k. So y of n equal to, if k is 0, then k is 1, k is 2. So this is the expression. So h of 0 into x of n plus x of n minus n minus 1 plus h of 1 into x of n minus 1 plus x of n minus n minus 2 plus up to h of n by 2 minus 1 into x of n minus n by 2 minus 1 plus x of n minus n by 2. Let it be considered as equation number 1. Okay, so now we draw the direct form. So this is h of 0 into h of 0 into x of n plus x of n minus n minus 1 x of n plus x of n minus n minus 1 into h of 0. Okay, plus h of 1 into x of n minus 1 x of n minus 1 plus x of n minus n minus 2. Okay, into h of 1 into h of 1, right? Up like that, x of n minus 2 like this. So this will be the diagram y of n. This is x of n. Okay. For direct form realization, total number of multipliers required is n number of multipliers. For linear phase realization, n is even. Total number of multipliers required is n by 2. Okay. Right. Next, coming to case 2, if n is odd number. Before one is n is even number. If n is odd number, then h of z equal y of z by x of z, then it will become sigma n equal 0 to n minus 1. So this is same. But here it will be divided as sigma n equal to 0 to n by 3 minus 2 h of n into z power minus n plus h of n minus 1 by 2 into z power minus n minus 1 by 2 plus sigma n equal to n plus 1 by 2 to n minus 1 h of n into z power minus n. Put n equal to n minus 1 minus n. So m will become n minus 1 minus n. So if n is n plus 1 by 2, then it will become m will become n minus 1 minus n plus 1 by 2. That is n minus 3 by 2. If n is n minus 1, then m will become 0. So h of n minus 1 by 2 into z power minus n minus 1 by 2 plus sigma n equal 0 to n minus 3 by 2. Okay, into h of n into h of n into z power minus n. Okay, plus sigma m equal to n minus 3 by 2 to 0 h of n minus 1 minus m into z power minus of n minus 1 minus m. So in the first place, n is replaced by n minus 1 by 2. In the second case, this n is replaced by n minus 1 by 2. Then it will become n. Then third case, this n is replaced by n minus 3 n plus 1 by 2. So this is minus 3. N equal to n minus 3 by 2 to. Okay. This one put m equal to n. M equal to n. Then replace n by small n by m. Small n by m. Then h of n will become h of n minus 1 minus n. Okay, so this is h of n minus 1 by 20 therefore minus n minus 1 by 2 plus sigma n equal 0 to n minus 3 by 2 into h of n therefore minus n plus sigma n equal 0 to n minus 3 by 2 into h of n into this one. So this is h of n minus 1 by 20 therefore minus n minus 1 by 2 plus sigma n equal 0 to n minus 3 by 2 into h of n is common z4 minus n plus z4 minus n minus 1 minus n. Okay, so this will become sigma k equal to 0 to n minus 3 by 2 into h of k into z4 minus k plus z4 minus of n minus 1 minus k plus h of n minus 1 by 2 into z4 minus of n minus 1 by 2. Okay, so y of z will become x of z into this entire thing. So after that we will apply inverse z transform so that we will get y of n is this expression. For this we will draw the diagram x of n. Okay, next x of n minus n. Okay, both are added. Both are added and multiplied by both are this one and this one are added multiplied by h of 0. Okay, next x of n minus 1, x of n minus n minus 2, x of n minus 1 and 2, and this is x of n minus n minus 2. These two are added. It will be multiplied by h of 1. Okay, and then this one and this one. So this is the diagram. For n is odd, number of multipliers are n plus 1 by 2. Okay. Now do some problems. These are all the problems. Realize the following system using direct from a linear phase. So the given problem is h of n equal 1 by 2 into delta of n plus 1 by 3 into delta of n minus 1 plus delta of n minus 2 plus 1 by 4 into delta of n minus 3 plus delta of n minus 4. Okay, plus 1 by 3 into delta of n minus 5 plus 1 by 2 into delta of n minus 6. Okay, so in direct form, h of n equal to, so 1 by 2, 1 by 3, 1, 1 by 4, 1, 1 by 3, and 1 by 2. So here the length of h of n is h of n is 7. Okay, 7. So h of z, that is n equal to 0 to 7 minus 1, 6. H of n is z4 minus n, that is this inverse z transform will get
ఉన్నాయి ఇప్పుడు కొద్దిగా మంచిగా ఉన్నాడు పెట్టుకో.
okay, plus x of n minus 2 plus 1 by 4 into x of n minus 3 plus x of n minus 4 plus 1 by 3 into x of n minus 5 plus 1 by 3 into x of n minus 6. Okay, so by direct form, x of n into 1 by 2 plus x of n minus 1 into 1 by 2. Okay, x of n minus 3 into n minus 3, x of n minus 2 into 1. Okay, తర్వాత x of n minus 3 into 1 by 4, x of n minus 4 into 1, x of n minus 4 into 1 by 3, x of n minus 6 into 1 by 2, all are added, and sum is the total sum, so that we will get YF. This is relative. This realization requires number of multipliers 1, 2, 3, 4, 5, 6, 7, 7 multipliers. 7 multipliers are there. Number of adders are 1, 2, 3, 4, 5, 6, 7 minus 1, 6 are there. Number of memory elements are also 6. By using linear phase math technique, we know condition for linear phase filter as h of n equal to h of n minus 1 minus n, all values of n. So for n is 7. So n is 7. So h of n equal to h of 7 minus 1 minus n. So 6 minus n. If n is 0, then h of 0 will become h of 6. H of 6. If n is 1, h of 1 will become h of 5. N is 2, and h of 2 will become h of 4. And h of 3, if n is 3, h of 3 will become h of 1 by 4. Given system satisfies linear phase condition. Okay. So h of z equal to this one. So it was already done. So y of z is this is h of 0 plus h of 1 into like this is right. So replace these conditions. So h of 0, h of 6 is replaced by h of 0, right? And h of 1 h of 5 is replaced by h of 1, h of 4 is replaced by h of 2, h of 3 is h of 3, right? So that h of 1 into it will become, this is h of 1 into z, h of 0 into this one, h of 1 into this one, h of 3 into this one, and h of 3 into this one. Okay. Now we will apply inverse check transform and linearity property. Then y of n will become h of 0 into x of n plus 1 into x of n minus 6 plus h of 1 into x of n plus x of n minus 5. This h of 2 into x of n minus 2 plus x of n minus 4. H of 3 into x of n minus 3, right? So for this equation, we will draw the linear phase structure. So x of n and x of n minus 6 are added. These n minus 6, these two are added, which will be multiplied with h of 0, that is h of 0 equal to 1 by 2. Okay, plus x of n minus 1 and x of n minus 5. These two will be added, which will be multiplied by h of 1, that is 1 by 2. Similarly, x of n minus 2 and x of n minus 4 will be added and will be multiplied by h of 2, that is 1, and x of n minus 3 into h of 3, right? H of 3 is 1 by 4. All will be added here, that is y of n. Number of multipliers is n plus 1 by 2, that is 4. 4 multipliers are there. So 1, 2, 3, 4. And adders are 1, 2, 3. N minus 1 by 2. Okay. 6 by 2, that is 3. And memory of 6, 6 and we want 6. So next h of n is this one, linear phase. So n equal to 8. So h of condition for linear phase and h of n equal to h of 8 minus 1 minus n, that is 7 minus 1. Okay. So substituting n values 0, 1, 2, 3, we get these values. So after that we will get the expression like the same like the above. The cascaded and this is h1 of z, this is h2 of z. So we'll write y1 of z, y2 of z. After that y1 of n and y2 of n. So y1 of n, the output of y1 of n is connected to the input of this one. So these two are connected in cascaded manner. Okay. y1 of n, x1 of n plus x, x1 of n minus 2 into 1 plus x1 of n minus 1 into 1 by 2. So that is added with the n, that is h2 of n, h2 of n into 1 by 2. So n into 1 by 2, right? After that, h2 of n minus 1, h2 of n minus 1 into 1 plus 1 by 2 into h2 of n by 2. 1 by 2 into h2 of n by 2. So this will be added, and that is y2 of n, that is equal to y of n. Okay. This, these are the FIR filter techniques. IIR and FIR filter techniques. In IIR filter techniques, we have 7 techniques are there. In FIR filter techniques, we have 3 techniques are there. So these are very, very important. We have to practice it on paper. Then only we can understand. Okay. So make it practice on paper. Take the same problems and practice it. Thoroughly practice it so that you can understand well. Okay. With this, I am concluding the today's class. Okay. Tomorrow we'll start the next topic. Okay. Okay. Thank you.